Welcome dear students. In the previous class we have discussed about the elements and their subshell electronic configuration and how we can find the group number, period number, block of the element by using the subshell electronic configuration. Today we are going to discuss the properties or characteristics of elements in each block. What are the general characteristics of the elements in each block we want to discuss here. Okay, it's a very simple topic and we want care more about the D and F block elements. But they will ask the question from S and P block elements also, but we want to very clearly hear the things related with the D and the F block elements. S and P, that's a known thing for you. Once more we can just revise that ideas related with the S block elements. So today we are going to discuss about the characteristics of elements. First of all, we are going to discuss the characteristics of S block elements. Okay, characteristics of S block elements. What are the general characteristics of S block elements? Generally, first and second group elements are the S block elements. Okay, so they are generally first group generally known as alkali metals, second group generally they are known as alkaline earth metals. Except hydrogen, the other elements are metals in their nature. Then at the time of reaction they can donate electrons. They will donate electrons in a chemical reaction. They will donate an electron in a chemical reaction. Especially the first group elements, their valence shell contain, for example, 1s2, 2s2, 2p6, 3s1, atomic number 11. This is the valence shell, third shell, that contain one electron. So that will donate one electron in a chemical reaction. So generally, the S block elements, especially the first group element, will donate one electron. So always they have +1 oxidation state. S block elements in the first group, they have the +1 oxidation state. Then second group element, for example, 1s2, 2s2. 1s2, 2s2 is an S block element and group number 2. The valence shell, second shell, contain 2 electrons. So at the time of a chemical reaction, they will donate the 2 electrons. So that's why their oxidation state will be +2. So we can generalize this idea. S block elements have a fixed oxidation number. There should be a positive oxidation number. S block elements have positive oxidation number. For first group elements there will be +1. In the second group elements it is +2. Okay, they have a positive oxidation state. Because of donating electrons at the time of chemical reaction, the compounds are ionic in nature. The compounds are ionic in nature. Compounds are ionic in nature. Especially the S block belongs to the left side of the periodic table. S block, that means first and second group, in the left side of the periodic table. Because of the position, they have some more characters. So we want to know that characters we have studied in periodic table in the 9th standard. What are the characters? First one, they have low ionization energy. Low ionization energy. They have least ionization energy because in a periodic table from left to right, ionization energy will be increases. That's why they have low ionization energy. The second point is that they have low electronegativity. Low electronegativity. They have low electronegativity is there for the S block elements. Okay, they have low electronegativity. Then we have know that compounds are ionic in nature. Compounds are ionic in nature. Then another topic is that generally they show positive oxidation state. They show positive oxidation state. It should be +1 or +2. Have a fixed oxidation state, that is +1 or plus 2. Okay. Next one, they have more metallic character. They have more metallic character because S block elements, they are generally metals, so they have more metallic character. These are the general characteristics of S block elements. First of all, they have low ionization energy, low electronegativity, then compounds are ionic in nature. The next one, positive oxidation state, there is a fixed oxidation state for them that have +1 or +2. Then more metallic character in nature, they are metals, that's why they are more metallic character. These are the general characteristics of S block elements. These are the general characteristics of S block elements. Next one, we have to know the characteristics of P block elements. Characteristics of P block elements. Okay. Next one is for P block. We know that the P block is from 13th group to 18th group. Okay, 13th group to 18th group are generally known as P block elements. From boron family to noble gases, they are known as P block elements. For this block, there's a special case is that include metal, non-metal, metalloids and noble gases. Okay, this block includes metal, non-metal, metalloids and noble gases. Generally noble gases are non-metals. We just conclude that they include metal, non-metal and metalloids are included only in the P block. Okay, the P block contains, they have metals and non-metals like oxygen, nitrogen, then metalloids and noble gases are also there. Then the elements have exist in the solid, liquid and in the gaseous stage. The three states of elements are included in the P block. So the two characters, the P block include metal, non-metal, metalloid and noble gases. Then solid, liquid and gaseous are present in the P block. Okay, the P block elements that have solid, liquid and gaseous elements, they include the metal, non-metal, metalloid and noble gases, and also the element with the highest electronegativity. Element with the highest electronegativity. Elements with the highest electronegativity will be included in that block or in this block. In this block, that means in P block, that contain element with the highest electronegativity. It not implies all elements have highest electronegativity, is not there. Some of the elements have the highest electronegativity and the element with highest electronegativity, that is fluorine, is included in the P block. Okay, the element with the smallest structure or the smallest atomic radii are also included in the P block. These are the general ideas involved with the P block elements. P block elements that include solid, liquid and gaseous elements and metal, metalloids, non-metals and noble gases are also included in the P block. And the element with the highest electronegativity are also included in the P block. These are the some properties or characteristics of P block elements. Okay, P block elements. Then they have a fixed oxidation state. They have a fixed oxidation state. That may be positive or negative, but the number is always a fixed number. For an example, atomic number 17, chlorine, subshell electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. If you look at that here, that is a valence shell, third shell. The third shell contains 7 electrons. So it's easy to accept one more electron to attain the stability. That's why it will accept electron minus and one electron is accepted -1. So that is the oxidation state. For chlorine, its oxidation generally always will be, it is -1. So that have a fixed oxidation state. That may be minus or plus. For another example, aluminium, its atomic number is 13. If you write the subshell electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. The valence shell, third shell contain 2 plus 1, 3 electrons. To attain the stability, it is easy to donate the 3 electrons. So donating plus 3 electrons are donating, so plus 3. That is the oxidation state. For the aluminium, the oxidation state generally always it is plus 3. So that I have a fixed oxidation state. For elements belongs, it may be positive or negative, but the value is a fixed number. Okay, that is the case of P block elements. Then we are going to discuss the important characters of D block elements. First of all, we just want to know what are the characters of D block elements, and next we are going to explain that. Okay, what are the characteristics of D block elements? The first one and the important one, all the elements are metals, or D block elements are metals. Next, second point, they form colored compounds. They form colored compounds. They form colored compounds. They have to possible to form colored compounds. And the third one, they show similarity along group and period. They show similarity in properties. Similarity in properties. Similarity in properties along group and period. Group and period. And the fourth one, they show variable oxidation state. They shows variable oxidation state. These are the main 4 characters of D block elements. So look at here. D block elements, their 4 properties are written here, characters are here. They are metals, because transition metal, we are saying group number 3 to 12, they are transition metals. So the elements are metals. Then second property, they form colored compounds. Due to the presence of ions, they form colored compounds. Then similarity in property along group and period. They show similarity in their group and also in the period. Generally the elements shows similarity along group. That's why we are considering each group as a family. But in the case of D block elements, they shows similarity along group and also in period. Okay, what is the reason for that? We have to discuss. Next one, variable oxidation state. It's very important. Variable oxidation state. How they show the variable oxidation state, and how can you find the oxidation number in a compound? These are the things we want to explain here. For the 2 cases, for the 2 characters, we want to explain. So listen here. The third property we are discussed, they show similarity along group and period. What is the reason for that? For example, 21, generally the elements shows similarity in group. There is no need of an explanation why they show similarity along group, due to the number of valence electrons are equal. But we want to discuss the similarity in period. So 21, 22 and 23, just take the 3 elements, okay? And also then we can take 28, then 30, because 24 and 29 are special cases, you just randomly take the elements 21, 22, 23, 28 and 30. Okay, look at the valence electronic configuration. It does not write the complete electronic configuration. We need only the valence electronic configuration. That is, valence electronic configuration is 3D1, 4s2, 1s2, 2s2, 2p6 up to 3p6 is there. I just write the valence electronic configuration. So 4s2, 3D1. In this case, 4s2, 3d2, that is 3d2, 4s2, then 4s2, 3d3, that is 3d3, 4s2, then 3d8, 4s2, in 30, 3d10, 4s2. This is the valence subshell electronic configuration. Now look at that. In a chemical reaction, generally the valence electrons take part in the chemical reaction. So look at here, the valence electron, here the valence shell is the 4th shell. Third shell is the penultimate shell. It is not the valence shell. This is the penultimate shell, inner shell to the valence shell, generally known as penultimate shell. So penultimate shell contains 2 electrons. Here, sorry, the valence shell contains 2 electrons. In this all elements, the valence shell contains 2 electrons. Okay. So for all elements in the same period, their valence electrons are equal. If the valence electrons are equal, they shows similarity along period also. The valence electrons are equal, that's why they show similarity in their period. Okay, in group they show similarity due to the number of valence electrons, and here also in the period also the number of valence electrons are equal. Why the valence electrons are equal in a period? Because rather than the other elements in groups, in D block the last electrons are filled in the penultimate shell. The last electron are filled in the penultimate shell. That means at first the 4s subshell is filled, that is 4s 2. After that the D subshell in the 3D subshell is filled. That means 4s, that the fourth shell is the valence shell and third shell is the penultimate shell. So last electrons are filled in the penultimate shell. There is no change in the number of valence electrons, because only change will take place in the number of penultimate shell electrons. Because the last electrons are filled in the, that is most important, the last electrons are filled in the penultimate shell. So there is no change in the number of electrons in the valence shell. The number of valence electrons are equal. The number of valence electrons are equal in all the cases. So the elements shows similarity along their group and period. That is the reason. Okay, if you write the shell electronic configuration, we get the idea. For 21 the electronic configuration is 2892. 2892. For 22 it is 2812. Okay, 2812. Now you get the idea related with that. What about 30 is electronic configuration 28182. Look at here, the number of valence electrons are not changed. Number of valence electrons are equal, but there is a change in the electrons in the third shell, as in the penultimate shell. Due to that, we can say that the number of valence electrons are equal. In period, they show similarity in their property along period also. That's why it's a very important property of D block element. They show similarity in their property along group and period. Okay, now we want to discuss the variable oxidation state. Why the elements show variable oxidation state? For that purpose, we want to take 3 compounds of a D block element. Sorry, 2 compounds of a D block element. That's familiar example. First one, it is FeCl2, and second one, it is FeCl3. These are the 2 compounds of Fe, iron. Fe, atomic number 26, is a D block element that forms 2 compounds. One is ferrous chloride. This is ferrous chloride. FeCl2, that is known as ferrous chloride. And second one, FeCl3, ferric chloride. So ferrous chloride and ferric chloride. These are the 2 compounds here. FeCl2 ferrous, FeCl3 ferric. Okay, these 2 compounds, we want to find the oxidation state of Fe in these 2 cases. And we know that the chlorine is oxidation number is -1. We have just explained just before. The oxidation state or oxidation number is -1. By putting that value in here, we have to find the oxidation state of Fe also. For an example, in the case of FeCl3, in the case of FeCl2, chlorine, its oxidation state is -1. Here Fe, we don't know the value, that's why just give the value as X. We want to find the oxidation state of Fe, it is X. Now, how many Fe atoms are here? Only 1. So the total charge of Fe is equal to X into 1, because only 1 atom. Then what is the total charge of chlorine here? The total charge of chlorine is -1 into 2. If you add the charge of Fe and Cl, we want to get the answer is 0. Why? The compound is electrically neutral. So we can write the value here, it is 0. The total charge is 0. X into 1 is equal to X. We want to add the values, or we want to find the sum of the values. So we just put plus. Then -1 into 2, that is -2. So X minus 2 is equal to 0. Then we want to know the value of x. Just move the position of minus 2. We get x is equal to plus 2. X is equal to plus 2. From that, we have to find that the value of Fe, the oxidation state of Fe, here it is plus 2. So in FeCl2, what is the oxidation state of Fe? Fe is a plus 2 ion. Plus 2 ion. If you have a charge, we just give that as ions. So Fe plus 2 ions or Fe2 plus ions. The second case, the second example, FeCl3, ferric chloride. FeCl3. Students, please listen. How you find the value of Fe here? Oxidation state of Fe here. For here, chlorine have minus 1. Then we don't know the value of Fe, it is x. Then how many Fe atoms? Only 1. So x into 1 plus minus 1 into 3. Fe, the value is x. We don't know the value. How many Fe atoms? Only 1 atom. Then minus 1 is the value of chlorine. Then 3 chlorine atoms are there. So we can write x into 1 plus minus 1 into 3. X into 1 is equal to x and minus 1 into 3 is equal to minus 3. The total sum is equal to 0. So x minus 3 is equal to 0. We want to know the value of x. For that we want to change the position of minus 3 into the right side. We get x is equal to plus 3. So the value of Fe, the oxidation state of Fe in FeCl3, it is plus 3. So Fe have plus 3 oxidation state. These are the two compounds of Fe. One is FeCl2 and another one is FeCl3. One is ferrous chloride and ferric chloride. These two are compounds of iron. In the first case, Fe have a plus 2 oxidation state. In the second case, Fe have the plus 3 oxidation state. Same Fe, but their oxidation states are different. So we just implies that the element that have variable oxidation state. This case generally explained in the case of D block elements. It's a common example. Why they show this variable oxidation state in this case? We want to explain that by using the subshell electronic configuration. Students, please listen. The subshell electronic configuration of Fe we want to write. For that, Fe, its atomic number is 26. And if you write the subshell electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6. For our comfort, we just write 4s2, 3d6. Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. But the filling order is 4s2, 3d6. I think you get the idea why we write like this. Then, what is the meaning if you write Fe plus 2 or Fe2 plus? That means in the chemical reaction, Fe donated 2 electrons. Fe donated 2 electrons from the valence shell. Fe donated 2 electrons from the valence shell. So, which is the valence shell here? Fourth shell. The fourth shell means that have S subshell, that have 2 electrons. From where the electrons are donated? From the 4s subshell. Then, how you write the subshell electronic configuration of Fe plus 2 ion? How you write the subshell electronic configuration of Fe plus 2 ion? We can write the subshell electronic configuration of Fe2 ions plus 2 ion. We want to know Fe atom donated 2 electrons. Fe atom plus donated 2 electrons. The 2 electrons are lost from the valence shell, that is the 4s shell. So we can write the subshell electronic configuration of Fe plus 2, 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6 because the 4s electrons are donated. You get the idea? Okay. The next one, we are just find the value. It is Fe plus 3. What is the meaning of Fe plus 3? Or Fe plus 3 ion? Fe atom, iron atom donated 3 electrons. 3 electrons are donated by the Fe atom. From where the electrons are donated? The electrons are always donated from the valence shell. Okay, in this case, we want to compare the energy of 3D and 4s because the last shell contain only 2 electrons. But in this case, that how to donate the one more electron to become +3. We know that if we compare the energy of 4s and 3d, there is a least difference in their energy. In some cases, if the 4s electron are donated, there is a chance to donate electrons from the 3d subshell because of the least difference. Okay, because of the least difference in the energy, in 4s electrons are donated from the atom, there is also a chance to donate the electron or liberate the electron from the 3d subshell also. That's why the elements shows variable oxidation state. Okay, how you write the +3 ion electronic configuration of the Fe+3 ion? 3 electrons are donated. At first, the 2 electrons from the 4s subshell and 1 more electron from the 3d subshell. Now we can write the subshell electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. This is the subshell electronic configuration of Fe+3 ion. Generally, this case, this transfer of electron from the 4s and 3d nearest subshells, that is not possible in the case of S and P block elements. It is possible in the case of D block elements. That's why they have shown variable oxidation state. Number of examples are there. We have to explain only in the case of FeCl2 and FeCl3. So we want to know they have the 4s and 3d have least difference in their energy. So there is a possibility to donate the electron along with the 4s from the 3d subshell also in some cases. That's why the D block elements show variable oxidation state. So students, we discussed the 4 properties or characteristics of D block elements. The first one, they are metals, and second one, we are explained they show similarity along group and period, and the last point we are explained there, it is the variable oxidation state. They show variable oxidation state for the D block elements, and also we are explained, or we have just discussed, the compounds of D block elements are colored, or they form colored compounds. For an example, CuSO4, copper sulfate, it's a blue colored salt, the salt of copper. Copper is a D block element, so it forms colored compound. Then we know that FeSO4, ferrous sulfate, FeSO4, it's a green colored salt. So Fe is a D block element. Then we know another one, sodium chloride, common salt. It is colorless because sodium is a S block element. So generalize that the compounds of D block elements are colored compounds, or D block elements have possible to form colored compounds because of the ions. Okay, that is the case of D block elements. Then we are going to discuss the last point of this chapter, characteristics of F block elements. Characteristics of F block elements. What are the characteristics of F block elements? Generalize the idea. The F block elements are generally known as inner transition elements. F block elements are otherwise known as inner transition elements. And the inner transition elements, otherwise they have two names. One is lanthanoids and actinoids. After lanthanum, the elements are known as lanthanoids, and after actinium, the elements are known as actinoids. So the F block means they have two rows. First one, lanthanoids and actinoids. The general properties of F block elements, they are actinoids are generally radioactive in nature. Actinoids are generally radioactive. They have to possible to liberate radiation. So radioactive in nature. Then they are artificial elements. Artificial means they are man-made elements. Okay, they have the radioactivity, active nature. Then artificial, they are artificial elements. Actinoids are artificial, man-made elements. Then they are used in as what? Catalyst in petroleum industry. Catalyst in petroleum industry. First one, radioactive in nature, artificial. Then they have used as catalyst in the petroleum industry. Then uranium, thorium, plutonium. These are the elements in F block. They are used as fuels in nuclear reactors. They are used as fuels in nuclear reactors. Nuclear reactors like uranium, thorium, plutonium are used as fuels in nuclear reactors. So what are the characteristics of F block elements? They are radioactive in nature. They are artificial elements, that is actinoids are artificial elements. Then they are used as catalyst in the petroleum industry. They are used as catalyst. Then uranium, thorium, plutonium, etc. are used as what? Fuels in nuclear reactors. So these are the main topics we are covered in this chapter, that is periodic table and subshell electronic configuration. First of all, we are discussed the subshell electronic configuration of elements and the special case 24 and 29, and there what is the reason for their special nature, and we have just explained the short form of subshell electronic configuration, and by using the subshell electronic configuration how we find the block, group and period of an element. Then now we are discuss the characteristics of 4 blocks: S block, P block, D block and F block, and some of the characters have need some explanation, especially for D block elements. For that also we are explained. So all of you just care about this chapter and completely revise the chapter again and again. You will get good marks for your examination. Thank you, students.